Hi, welcome to Making the mangoPi. I'm your host, Crispy. In this series, I'm going to take you through my PCB design process, how I went from an idea in my head to a PCB in my hand. But before we get started, I have a few things that I want to discuss. The first is that I have a GitHub repo for the mangoPi revision 2 linked in the description down below. There, you'll find the PDF schematics, the BOM for the board, the Gerber board layout files, and finally, the EasyEDA project files. The next thing I want to cover is that this series is not intended to be a step-by-step guide for how you would make an FPGA development board. Rather, it is intended just to give you a general idea of my PCB design process. Though I am thinking about making a tutorial for how you would design your own FPGA development board, so if you would like to see that series, then let me know in the comments down below. The last thing I want to cover is that I am not an expert. I am completely self-taught in PCB design and FPGA development. So if you see that I'm doing something weird or completely wrong, then please let me know in the comments down below. But with all those things covered, let's dive into the changes that will make the mangoPi revision 2 into the revision 3. I've gone ahead and added all the components that I think I'll want on the revision 3 of the board so that I can make a general plan of where stuff will go. Though it should be noted that this is not the final board I will use. I need to first make a schematic that shows how all these components will interconnect, and then once that's done, I'll generate the board from that schematic. The first major change from the revision 2 to the revision 3 is that I want to make the board smaller. Hi, I'm future editing Crispy. I realize that I didn't explain what you're actually looking at here, so I'm going to do that right now. This is a PCB layout using EasyEDA. EasyEDA is a free PCB design software that I'll link in the description below. The PCB layout gives you a top-down view of the board. PCBs have layers. You can think of a PCB like a sandwich. The top layer of a PCB is like the top slice of bread. The next layer down would be a piece of lettuce, the layer below that a slice of cheese, and so on all the way to the bottom layer, which would be the bottom slice of bread. All of these layers are used for routing traces, which are the wires that connect your circuit together. But the top and bottom layers also have pads that allow you to solder components to your board. A pad on the top layer will show up as red. A pad on the bottom layer will show up as blue. A collection of pads arranged to connect a specific component is known as a footprint. Here's the footprint for the FPGA, and here's the footprint for the Ethernet PHY. Note down here is where the card plugs into the PCIe connector. And that's pretty much it. Back to the video. The first major change from the revision 2 to the revision 3 is that I want to make the board smaller. This will make it so that it's much easier to integrate in your projects. The revision 2 of the board measures 135mm by 105mm, while the revision 3 will measure 100mm by 100mm. The second major change is that I want the revision 3 to be compatible both with the current revision 2 FPGA as well as a slightly larger one. Now I'll cover this in more detail in a later video, but I think if I add a few more capacitors underneath the FPGA as well as increase the output of my power supplies, then it will work just fine. The third major change I want to make is I want to upgrade the Compute Module 3 Plus to the Compute Module 4. Now this has several benefits to it. It's easy to implement Ethernet, there's a smaller size, there's a PCIe lane, and there's Wi-Fi built right in onto the board. The next major change I want to make is with the SRAM highlighted here. Now I'm actually going to slow it down a little bit, but I'm going to double the capacity of the SRAM. I think that this will be much more helpful in future projects to have the extra capacity versus the speed. Now the next change you'll notice is that there is no USB input to the mangoPi revision 3. This is because I decided to remove that interface because it added extra space, and I feel that the compute module can actually do all the roles and responsibilities of that interface. That being said though, as I stated earlier in the video, I'm all self-taught with this, so there's a good chance that I could be completely wrong about that. So if I am, let me know in the comments down below. Finally, you'll notice that there are no more display ports at the bottom of the board. Those have been swapped out with a PCIe 4X Gen 1 or Gen 2. This was a tough decision to make because honestly, my knowledge of DisplayPort, my knowledge of PCIe is pretty much the same in that I don't really know anything about them. But I do think it'll be really useful to have such a high bandwidth interface between the compute module and the FPGA, or the FPGA and your PC. So I want to give it a try. And with that said, that brings us to the end of this video. In the next video, we're going to take a closer look at the FPGA, how you configure it, as well as the power supply for the board. Thank you so much for watching. I'll see you in the next video.